I'm going to give a quick tutorial on doing percent change calculations. Now, if you're already familiar with how to calculate percentages, feel free to skip this tutorial. This is for those of you who are either rusty on your math skills or if you need to brush up on your math skills. Whatever, it's okay. I'll bring you up to speed as needed with some basic math skills that you're going to need quite a bit, some concepts that we're going to use quite a bit in this course. Okay, so let's begin with a definition. Percent change in the value of a variable. Usually in our case this is going to be over time, expressed in a percent per 100 basis. Okay, you know what percent means, per 100, so we're going to normalize everything to a base of 100. Okay, and then percent change is just going to be the change in that variable expressed in a per 100 basis. So let me give you some examples. One concept we'll use quite a bit in macroeconomics is real GDP. So we'll look at questions like what's the change in real GDP from, say, one year, 2011, to another year, 2012. This would also be known as real GDP growth rate. We could do something like change in the consumer price index, which is one of the most commonly used measures of the general price level. And again, we could do it over a year time, so we could go, say, from 2011 to 2012. We could do it over even a shorter period of time. We could say from January 2013 to February. We could do a 1-month change in the consumer price index. Or we could do a long run. We could say from 1913 to 2013. Okay, and what this is going to give us, this would be the annual inflation rate. This right here, this would be the annual inflation rate. This right here would be a monthly inflation rate. Or this down here, this would be a 100-year inflation rate. To answer any kind of question like this, okay, change in any variable over any time period in a percentage basis, we're going to need the percentage formula. Okay, so here's the formula. It's quite simple, and I'm just going to write it in kind of intuitive language here. We're going to take the second number, or it's comparing two numbers with a percentage change. Second number minus the first number. Okay, you do that calculation first, so you subtract the first number from the second number. It's important that you subtract the first from the second, because we're usually going forward in time. Okay. So this is how much bigger or smaller is the second number than the first number. And then you simply divide that by the first number, and then you take that whole result and multiply it by 100 to put it in percentage form. Okay, let's do some examples. Real GDP per capita, concept that we'll use quite a bit in this class. We're going to see what the change in real GDP per capita was from 2011 for the US to 2012. Real GDP per capita for the US in 2011 was $42,620. For 2012, it was $43,270. Okay, now remember the calculation is the second number. So I'm going to take 43,270 minus the first number, 42,620. Take that difference and then divide it by the first number, 42,620. Take that whole thing, multiply it by 100. Don't be shy if you need to bring up a calculator here. 43,270 minus, what's my other number here? 42,620 is 650. So my simplified result here is going to be 650 divided by 42,620. And we'll do the math on that. 650 divided by 42,620. And that equals, now we don't need to use all these decimals, of course, 0.015. Probably close enough for us. Okay, and we're going to multiply that result by 100, remember. And you can do that on your calculator if you need to. Of course, you also hopefully remember that that's equivalent to sliding that decimal place over 2 places. Okay, so I've slid it over 2 places, and I get a 1.5. Put that percentage sign on there because I multiplied by 100. That's my percent result. Okay, so What was real GDP growth per capita from 2011 to 2012? I'll give you these numbers, 42,620, 43,270. You do this math and you can confidently state real GDP growth was 1.5%. Let's do another example or two. Okay, let's do some inflation rate. So I'll give you a consumer price index number for January 2013, our consumer price index, which again you'll learn a lot about later in the course. This is a measurement of kind of an average level of all prices of all goods in the economy. Our consumer price index number in January 2013 was 230.28, and in February 2013 our consumer price index number had risen to 232.17. Okay, now we'll have a question along the lines of what was the inflation rate from January to February 2013? Well, the rate of change in percent terms, that's the same thing as what's a percent change in this number from January 2013 to February 2013. So we're going to apply that percent change formula. Now, I'll simplify the percent change formula here. I'll just use a generic variable x. And remember the percent change formula, x2 minus x1 divided by x1 times 100. So this we can probably do just on the calculator without writing it out. We know that our x2 is the February 2013 number, 232.17. Subtract that x1 number, which is 230.28. Our difference in the two numbers is 1.89. We're going to divide the difference by the first number, the January number. So divided by 230.28. Okay. And that gives us 0.008. We're going to multiply that by 100 to get our percent result, which is 0.82. So we could say we have an inflation rate here of 0.82%, just under 1% inflation from January to February 2013. Okay, so that's a percent change formula and how to use it now. Let me just show you here that you're going to be asked to do this several times. Here's on homework 2, working with GDP numbers. Okay, I'm going to ask you to calculate some GDP figures and then calculate the percent change from the prior year. Okay, so you're going to apply that formula. x2, which is going to be your result for this box, minus x1, which is your result for this box, divided by x1 times 100. On homework 3, you'll see this come up with the inflation rate. Percent change from year 1 to year 2. Now in this particular problem here, notice the years aren't consecutive. Okay, we're going to skip ahead. We're going to skip 18, 20 years, 22 years ahead. Nonetheless, the percent change formula is from this year to the next year, from this year to the next year, from this year to the next year, so on and so forth. And that's how I want you to interpret when I ask you a percentage change from year 1 to year 2. Okay, they don't necessarily have to be consecutive years. That's percent change. Learn it, live it, love it. It'll be very useful, both in this course and in your life in general.